Part 1. The Knights of the Order of the Golden Duck don superb armor and weapons, each adorned with mysterious symbols. While some of these may be mere decorative ornaments, many are powerful combinations of runic symbols that endow the items with extraordinary properties. Each aspiring knight must master these symbols to fully harness their magical powers. Such mastery demands knowledge and patience, for even the slightest error can lead to unforeseen consequences. The day of the exam is fast approaching, and you feel confident in your preparation. After all, you've studied diligently throughout the night. As the candidates gather in the grand circular hall, you see the object of your test, a knight's helmet. Though it appears ancient, the magical runes inscribed along its lower edge still glow with a bright, mystic light. Neat. Your task is to count all the runic words within the inscription on the helmet. Fortunately, the task is simpler than anticipated. A note beside the helmet lists all the possible runic words that may appear. With these in hand, you begin the task of counting. All right, so this is what my input's going to look like. Got it. So we have words, and then we have a bunch of lorem ipsum. Oh, that's neat. Look at that. It tells you the caret position. So if I click here, I'm on line 2, position 24. So we can see that this is 444 characters long. Neat. All right, I'm just going to click download so I don't mess up copy and pasting. We'll go to solutions, cargo new, DAO2. Is that what I called it? DAO1? Yeah, DAO1, DAO2. Let's pull in AOC lib workspace equals true. And maybe if I continue with these, I'll make something that'll just do all that for me. Okay, so make their input. Move, downloads, everybody codes into input. I gotta figure out a better way to do this. Let lines equals AOC lib read lines input / this. So it's going to be lines of 0 is going to be the words that we need, and then lines of 2 is going to be where we want to search. Oh, I see. We have the and her overlap. Okay. So we're gonna write a little part 1 function, which is going to take the words, and we're going to take a line, and it's going to return a usize, which tells us how many words there are. Oh, maybe what we do is we split this into a vec. Can we do this? Yeah, and then here we're going to make our test. Fn test part 1. And so what we'll do is we have these words here. And we can just quote, 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 quote. Let words equals this. And then we can say assert EQ. The first one has 3 runic words, and the line is this. Part 1 of words and this thing here. The next one has 2 runic words, and the next one has 3. Okay. All right, and then we're going to come over here and go to DAO2, bake and test. Okay, and I didn't save this yet, so let's save it. Okay, so now we write the code. So I think it's just, oh, we need to find all instances. Is there something in this string Rust, standard string, that will find all indices? Maybe it's in stir. Are match indices? Is there a match? Yeah, there's a match indices. An iterator over the disjoint matches of a pattern, not overlapping matter. That mean we have to just step along and do a starts with? Yeah, so that means an overlap. Yeah, right. It shows it here. ABA matches this first ABA, but not the second ABA because it overlaps. Is there a different? It is a more complicated algorithm to find the overlapping ones, obviously, right? But we could cheat and pull in another crate. All right, or we could just walk along. For I, index in line 0 dot dot line len minus, oh, let's say for word in words, and we can do this, let total 0 minus word len. Right. Let me do it this way, and then we can do it functionally. I think the functional might be a little less easy to read. If we can say total plus equals line of index dot dot starts with word as usize. It compiles. The test passes. All three tests pass. So now we just need to split things up. Start with the O dot dot slen filter I part. Yeah, well, I have this. Let me get this finished, and then we can flip it around to being functional. So we're going to say let underscore comma word list equals lines of 0 dot split once on the colon unwrap. Now word list is our words. Let's go here. Okay, it's just going to be this bit here. So let's say let words equals word list dot split comma dot collect vec. Good. And then the line we actually care about is lines of 2. So we can just say println part 1 equals this part 1 words lines of 2. And run. Ooh, that's not good. Right here, line 6. Oh, did we not read all the lines in? Oh, we skipped. That's right. My code skips blank lines. I forgot that we skipped blank lines. 27. All right. Let's get rid of this print statement. 27. Quack, yeah, you're crushing it. That's the right answer. 8 days, 13 hours. And we came in under 1,000. Nice. All right. So now the question is, do we want to make this functional? And we could start here, right? I mean, I know you said start on the outside, but if I start on the inside here, I can do this. Filter index count. All right, this should still be 20. Oops. Oh, IDX. It should still be 27. Oh. Oh. Nope. Oh, like this. It's still 27. Okay. And then we can say words iter map word this sum. $27. Okay. I did it the other way around, right? So because I was working my way backwards from my existing code. So, but I think they're both fine. The only annoying thing is this. I guess we don't strictly need to subtract the word len because the filter will filter all those out. Will that simplify the formatting? No. It's still splatted over 3 lines. Okay. All right, I'm going to go with that. Get status. Modified cargo locked, really? Oh, because I added day 2. Okay. Can I say git add dash a? No. Git add dot. Oh, dash capital A. Thank you. I'll say git commit dash m KOA 2024 day 2. Oh, quest 2 part 1. What did I call the other one? Oh yeah, okay. All right, so that was part 1. Part 2 shows up right here. Congratulations, your correct answer allows you to advance to the next chamber. This time your challenge centers around... Ooh. Centers around, huh? A colossal shield worn down over time and scarred from countless battles. Yet despite its age, the runic symbols etched upon it remain as vivid and clear as ever. The list of potential runic words is still at your disposal, but it has grown considerably longer. However, the objective of the task has changed. This time you're focused not on counting the runic words, but rather on counting the runic symbols that make up those words inscribed on the shield. Oh, okay. We just add the length of the word. The inscription sprawls across the shield in many individual lines, each demanding careful interpretation. Moreover, these inscriptions can be read from left to right or from right to left, meaning you must search for runic words in both directions. All right, so we have a bunch of tests here. Oh, yeah, no, I can't just add the length of the words, because when you have an overlap, you don't count the letters twice. Okay, so we can come up with all of these tests. Test, fn test part 2. It's the same set of words. That makes that part easy. So insert EQ. And this one's going to be 15. Part 2, words, comma, open quote. Awaken the power adorned with the flame's bright ire. Okay. This is 9. This is 6. And this is 7. Okay, the flame shielded the heart of the kings. This is power, yep. And then there is the end. Okay, and the test should fail because we don't have part 2. If I write a part 2 with 0. All right, so now we need to do forward and backwards. I guess what we could do is just reverse the line and then do part 1 on each one. Oh, no, that doesn't work. Part 1 is adding how many times the word appears, not how many times the letter appears. What we could do is create a second array, a vector, and then just, no. We could use a hash set. Rune pause. Let's call that. And then the result is going to be rune pause len. Let's pull this in. So now what we can do is we can find each location of each word in there. But we'll have to do it for both forwards and backwards. So let verse line is equal to line chars rev collect string. And that's going to make a string, not a stir. And now we can do words iter. We're going to look at each word. We're going to map the word to, we're going to look for all the positions that we can find that word. Oh, and then we have to update our rune pause. 0 ... line len minus word len. Can I do fold? This might be tricky. Of rune pause as our starting point, and then take the index and the new rune pause, and then check the line. Starts with word. Close the map. If it starts with a word, then we can add the length of the word based on the index that we're starting at. So rune pause. Like that. RP insert pause. Okay. Oh, I have this backwards. Yeah. Okay, so now, there. And this is just half of it. Oh. Dot. Mismatched types. What are we trying to insert here? And what does it think it is? Oh, and then I have to return the RP. Else RP. Oh, I guess we could just do it this way. Oh, can I do it this way? Oh, no, I can't. Okay, so I can't use the fold. I was hoping I could. So this becomes index, and this becomes rune pause, and then we don't need to return it. IDX. Yes. Uh-oh. Returns a closure that contains a reference to a captured variable. So yeah, but if I move it, then we lose it, right? That's too bad. Okay, so we just do it the hard way. For word in words. For line index in 0 ... line len minus word len. If line blah 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 starts with blah blah blah. And now we don't have any of that mess, but I am missing my, there's this thing here. Okay. And then we have to do it for the reverse as well. If rev idx ... starts with word, we want this, but backwards. So not pause, but line len minus pause, I think. And that passes those tests. Okay, even the overlapping one works. So should we do it for the real thing? Did I download it yet? I did not. Okay, let's download this. Ooh, this one's 21K. Let's take a quick look at it. Okay, so there's a lot more. Yeah. Okay, so we just need to add this up for part 2. We can grab the same thing here. Change part 1 to part 2. And instead of doing this, we're going to say lines 1 dot dot. And is that already an iterator, a map? Fold 0 comma part num line part 2 words line string is not an iterator, and run it. 71. That seems wrong. Oh, because I didn't change this. 8335. Holy quack, that's not the right answer. Answer length is correct. The first character of my answer is incorrect. I have to wait a minute before I can try again. Okay, the length is correct. Okay, so it's a 4-digit number, but it doesn't start with 8. That's what it's saying. All right, let me just double check on the tests here. Yeah, so the test passes. I wonder what test I'm missing. That's just that. Oh. There's a her. There's no test for backwards. I don't see one. Let's add one. Assert EQ. I don't know. Part 2 words. And let's just do some. So I just did it backwards MES with semaphore here. And I don't know, however, how many other ones. So it's saying there should be, it's calculating 3. So is there an HER? No. Is there a THE? No. Is there an OWE? No. There's an MES? No. And there's an ROD? No. So then the backwards is EHT. So actually it worked because it found 3 characters. EWO, SEM. There's the SEM, DOR, and REH. Okay. What about overlapping entries? I should be able to say THEWO, and that should add 5 more. So it should be a total of 8. Oh, it came up with 9. Must be this. I must be miscalculating this here. Let's just do this. And then line len minus pause. Oh, because it's doing the whole thing. Okay, let's split this out as a separate test. Test fn test overlap backwards. Okay, So we got 20, 21, and 22. Really? 1, 2. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 should have the thing. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. That's the. But it's not. Oh, yeah. And then, okay, that was the. Let's print out the word that we're actually finding. So we're looking for the, and we found it here on 20, 21, and 22. Then we're looking for O, O-W-E, and it found it at 0, which is 25, 20, 21, 22, 23. So it should be 24. Okay. So it should be -1 here. (24, 23, 22). And now it's 8. Okay. So that was probably the bug. Let's get rid of these print statements and run the real test. T? No, R. 5341. Okay, so it's still 4 digits, but it doesn't start with an 8, which is, I think, what the clue was. Caffeine says, are we double counting if a character is selected by 2 words? No, because I'm throwing everything into a hash set. So if it happens to already be in the hash set, then we ignore it. But that's a good point. That could happen. Okay, so we're in the right ballpark now. It should be 5,000 something. Because the first character, if my answer is correct. But I'm still all quacked up here. What else could be the bug? Caffeine Storm says, more tests. Yeah, I just need to know what to test. I did a testing of forward and backwards overlapping. I've got this as just a single backwards one. What if I test just I just put mess. So that should be 4, right? No, that should be 3, 6, 9, 12. Oh, aha, and it only came up with 9. Interesting. Why? Do I have to add +1 here? Maybe it's missing, and that means the first one's also wrong. No. Oh. You don't want to add the +1 here. We just want to add it here. There we go. Okay, so that was the bug. It wasn't finding one at the end. All right, so hit run. 5378. I'm quacking unstoppable. That's the right answer. I wish I really were unstoppable. That was the right idea, Caffeine. More tests. All right, that's good. I'm happy with that. That was part 2. Yeah. I should try to clean up how we do this. And it's interesting, we actually have 3 parts instead of 2 parts, which totally breaks my Advent of Code stuff. So git commit -am KOA 2024 quest 2 part 2. All right, let's see what part 3 is. You advance carefully to the final examination chamber where a set of scale armor awaits the candidates. This armor, unlike anything you've encountered before, is covered in scales, each etched with a runic symbol. The scales are meticulously arranged in a rectangular grid with the right edge seamlessly connected to the left, okay, forming an unbroken loop. In this challenge, the neighboring scales can form runic words both horizontally and vertically, left to right, right to left, top to bottom, bottom to top. Wow. All right. Your task remains as it was before, to find all runic words hidden within the armor and count the number of scales that compose them. Okay. So it's connected, the right edge connected, so we loop around this way. So it's THE. But I notice here it doesn't loop on the top. So it's ROD. ROD would normally be something because it goes left to right, right to left, top to bottom, and bottom to top. Which means it could be upside down, but it doesn't overlap vertically. I mean, it doesn't wrap around vertically, it only wraps around horizontally. All right. This is going to be a little trickier. Let's take a look at the input. Ooh. Wow. Oh. Why is it so? Oh, it's wide because of all these words. Oops. Went a little too far there. Okay, so let's see. We have a test case here. Let's enter our test case. Event test part 3. The words are going to be different now. I think I can just edit it in place rather than messing around. So we have the, o, mess, rod, and instead of her, we have rodeo. Our lines now are going to be these 3 strings. Okay, and now what we can do is say assert EQ part 3 words and lines. Okay, I'm going to generate part 3. Inline macro or a function with a similar name exists part 1. Why not create new okay. Caffeine Storm says, do you know about set pace? I do, but with something that simple, I wasn't really bothered by it. Event part 3, words stir, lines stir. I'm going to return usize. I'm going to just put a 0 in here, and we're going to put a ampersand there. Okay, so now we're going to loop over all the lines. Sorry, I'll loop over all the words and look in the lines for them. Left to right, right to left, top to bottom, bottom to top. If we make a hash map that maps every row column into a character, then we can then loop over all of the rows and columns, looking for each word. That seems like a very painful way to do it. I mean, let's give it a shot. We're basically taking a hash map of, let's say, I64 to character, char. Like this. Unknown, because I didn't pull in hash map. There we go. And now we can say for line, row, line, in lines, for lines enumerate, for call ch in line chars enumerate, matrix dot insert row as I64, call as I64 ch. And now I should be able to say, I should be able to loop through all of these things. All right, so at 1, 3, we have a G. That's correct. At 1, 1, we have an N. Yep. At 0, 5, we have an R. Yep. Okay, so that worked. For word in words. I guess we put total here. Or maybe we do the same thing with the hash set. And then we have to break the word down into each character. Let's do this. Let rows equals line len. Let calls. I'm assuming they're all going to be the same. And we say for R in 0 dot dot rows, for C in 0 dot dot calls. Oops, I put a space there. I don't think it matters. We're going to say if collect vec. I think I get the characters that way. I do. Oh, now we want to say, okay, we're starting at this row and column, R and C, and we want to walk our way along chars in all 4 directions. And see if we have a match. And if we do, for dir in that's to the left. Then we go to the right. Oh no, this is row column. That's up and down, and then we have left and right. Okay. Now we just want to check to see if wow. How many nested loops are we up to? We're up to 5 now. Let's say let mut equals R equals C as I64. Oops. And these are all going to be I64s. If ch is equal to matrix dot get rlock clock no, this is just getting worse and worse the more I write, because now we have to look up in the matrix to see if it's there. If rlock is less than 0, or rlock is greater than or equal to rows, or clock is less than 0, or clock calls, then we're going to say break next word. Oh no, next call. Then we know it exists. Unwrap. If it's not equal to, then we're going to say break next call. Okay. If we get all the way down to here, if we go here, then it's rlock plus equals dir 0, clock plus equals dir 1. We got all the way to here. That means the characters are all exist in the direction that we found. So now we have to put them into the rune pause. So rlock equals R as I64, clock equals C as, Wow, this is terrible. This is absolutely the worst code I've written on stream. For underscore in 0 dot dot word len. Rune pause insert rlock clock. Okay. Now what blew up? Unexpected token. Oh, okay. Oh, I guess this has to be like that. Getting closer. Oh, this has to be like that. We have to deref that. And we still got 0. After all that work, we still got 0. Where can we check to see? Oh, yeah, caffeine. You're calling that break a go-to? It is a little bit, right? Oh, maybe we have to go to the next direction. Maybe we have to go to the next direction. Maybe that's the problem. Nope, that wasn't the problem. Maybe we can decompose this in helpers and test the helpers. That's a good idea. What we want to do is, yeah, I'm trying to think of if I can just, because I normally just do printf or println debugging. Let me just do this really quick and see if we can figure out what kind of mess we're getting ourselves into here. So we're looking for T's. We found one here, but then, okay. Let's print out the word we're looking for. Yeah, so it found the T and then the H. But it compared it to an E. Why did it compare it to an E? Let's print out the row call. Yeah, so it finds the T here. Oh, it finds a T at 2, 0. Oh, it found a T at 1, 7. No, it found an L there. Wait a minute. Okay. 0, 1, 2, 3, 4, 5, 6, 7. It found a T, and it should have looked downwards at that point. At 1, 7. It should have looked here. Let's print out the DIRs. Oh, because this is, yeah, okay. Still doing a search up. Oh, it never got to the next dir. It never changed directions. Oh, because got it. So now it should try all the directions. Okay, now it's trying all the directions. We found 112 instead of what we were looking for. Let's get rid of that line. And then we can say we found, println found word at r, c, dir equals dir. And we can get rid of this. It found the at 0, 0 with going up? No, that's not right. Oh, yeah, because we can't assume that we got all the way here. I guess we have to do this kind of yucky stuff. Let mut found equals false. Oh, found equals true. Found equals false. And then here, if not found, if found. Let me do this. And now we're never finding it. So this doesn't actually need this here. Oh, that's right. I wanted to continue. And we're still not finding them. All right. So I think we have to finally break this down into separate functions. I guess what we can do is once we have a word, we know the characters that are in that word. We can look in each direction. Can we make this inner thing here part of our helper function? We're looking at, well, let's do this. I'm still stuck on printf debugging because I don't see an easy way to break this down. Oops. T then H. So it didn't find this. So it's trying each one of the directions from that, and it's finding the H. And then it moves on to the E. Okay. And here it finds a T going backwards. Oh, I see. Then it's going through the other three directions, but never coming in here. It must be this then. So where does it 07T then L? Yeah, it found the L. That's good. Yeah, there's probably a better approach. Instead of breaking it down into this matrix and trying to find it in a matrix. Oh, look, this should be doable. This should be totally doable. Oh, is it? Oh, I got this part wrong. That's why it says 07 again. It should say 17. Yeah, 17. It finds an L, so that's no good. And if we look all the way, oh, it found an O. Okay, so now it's finding stuff. Let's comment this out and this. Why did I get this dump here? Found an O, a rod, and a rodeo. Oh, and it didn't. Ah, right, because we're not searching backwards yet. That's weird. Why? I wonder why I got that other error there. The backtrace. All right, so we're searching. Oh, we're not looping. That's a problem. We're not looping. Okay. So the columns we don't care about. We just care about whether or not we're going to go off the row. The column is going to be easy enough. It'll be clock. I guess mod calls. No. Because if we're going to go backwards, we have to add clock equals calls as I64, else if clock is greater than or equal to calls, then clock equals 0. We're still operating on a none value, y -1. Okay, so now we're searching backwards. All right, should we get, did I download the thing? Part 3, I did. And did I move it? I did. Okay, so part 3. Println part 3 equals this. Part 3 words lines 1 dot dot. Oh. Yeah. Oh, I have to borrow. Okay. Doesn't like that. Oh, right, because it's Oh. Oh. Okay. Right. And now, what do we do here? Because I've been doing stirs all along. I wonder if I can just say as ref stir. I do that. Plus exact size iterator. Oh, no, as ref. Like that. There. Okay, so now if I hit run, whoops, let's quit out of that and get rid of the print statements. Because it's going to find a bunch. It's not fast. All right. And here's where we see if we quacked up or not. Give me a quacking break. Marian says, you're welcome. Thanks for streaming. I've been watching YouTube videos for months now. Oh, great. Thank you. Okay, so we're in the right ballpark. It's a 5-digit number and starts with a 1. But apparently this is not good enough. Oh, here's where I messed up. I still have to modify these things here. All right. It's very slow. Okay, 11,573. All right, so it's 1 digit wrong here. Come on. Come on. Come on. Submit. Hey, that's the right answer. Okay. This is very ugly code. I'm going to have it sit and think about the way this all works.